All right, now on this one, I want you to see the difference of what happens when we work inside the square root. So once again, we have on here, just get the basics down, we have the square root of x right here. So over 1 up 1, over 4 up 2, over 9 up 3. But what we got to understand right now is when we modify inside, watch what happens. It's not a vertically pulling, like stretching, or vertically compressing, even though it kind of looks like that's what's happening. From a graph, you got to think about the pressure coming from right to left. So this red one right here, look what this happens. Normally when I put in a 1, I get the square root of 1 out. Well, it's not doubling what I normally get as output. That would be 2 on the outside and root x on the inside. If I put a 1 in here, the 2 is making it root 2. So this 2, which normally when I put in a 2, I get root 2, now I'm getting 2. So I'm actually getting, what you got to think about these points moving this way. So I'm going to watch this point right here. So if you look at where my pen is, this is hard to explain, so I'm going to take some time here. Instead of going over 4 up 2, I only have to go over 2 up 2. Because what I'm essentially doing by putting the 2 on the inside is I'm making my input larger. So that 2 is really coming out as if it was a 4 because it's doubled before it gets to the output place. So this point is pushed that way. This point right here is pushed that way. And this point right here, look at it. Normally, what does it take? It takes me right 9 to get up a level of 3. Well, now with the 2, I'm getting up to a level of 3 at 1, 2, 3, 4.5 up 3. So on the horizontal one, you don't want to think about it as coming up this way. You want to think about the points moving right to left. So this point right here, like that's not on the blue graph that we see, the normal one, but it actually is. Because look, 1, 2, 3, 4, 5, 6, 7, 8, up 4. Well, this point would normally be on this one over 16 up 4 because the square root of 16 is 4. So that's why this is from this direction compressed. That's why it's called a compression and not a stretch. All right, it shouldn't take me as long to talk through the green one because it's having the opposite effect. If I put in 1/2 inside now, just think about this. Now when I put in a 4, I like here, I'm used to getting a 2 out. Well, I'm only getting a root 2 out. So I'm not getting a big enough value. So what's happening is, look at this. It takes me 1, 2, 3, 4, 5, 6, 7, 8, 9 to get up here. Okay? So this one, actually, hold on. That should have been at 8. That should be right here. That's my bad. It should be 8 because it's twice as much. So 1 is up 1/2. 1, 2, 3, 4 is up to normally, but now it's going to take me 1, 2, 3, 4, 5, 6, 7, 8 to go up 2. So this point has been pulled or stretched horizontally to that point right there. And if we look back at the table, that makes sense. Sorry that I put this in the wrong spot there. It was at 9, 2. It's supposed to be at 8, 2. But this right here is, if you put in an 8, think about it. What's half of 8? 4, square root of 4, 2. That's what's happening on the green graph. Okay? That is not an easy thing, and I wanted to use our class time a little bit differently, so I hope that helps you at least understand those a little bit. If not, please ask.